Welcome, everybody. Thank you for taking some time to join us today to go through going to the edge with NVIDIA and OKdo. We've got some interesting discussions to have, and we're looking forward to getting your questions and having some time at the end to get back round those and discuss how you can adopt edge computing, how you really get involved in helping drive that wider adoption and utilization of AI technology, particularly at the edge. Before we do that, I just want to introduce the guests today. I'll start with myself. So I'm Nick Young. I'm the Group Chief Digital and Innovation Officer at RS Group. And I'm also the President of OKdo, our IoT and single board computing offering. We have Samir Jabba, who's also with us today. He's the Editor-in-Chief on Edge AI Tech, working for Wevolver. It's great to have him with us. And we also have Eddie Seymour, who's a European Technical Director at NVIDIA and a great partner of ours equally. So I just want to start really by giving me a short introduction on who OKdo are, a bit of context, and then we'll get into the real detail of what is edge computing. So firstly, OKdo is a 4-year-old organization. It was born out of the RS Group, which has an 80-year heritage and is a FTSE 100 organization specializing in the distribution of industrial and electrical components. Where OKdo fits is we're really spearheading our efforts into the IoT, smart technologies, and single board computing offering. We have a real complete ecosystem of design, distribution, and manufacturing capabilities that support our efforts to really bring a rich community together to design a smarter future. To do that, we have tens of millions of pounds of inventory on hand globally. We have global field application engineers who are very customer centric and looking at supporting and partnering with our customers to help make their lives easier in that adoption process. We also have 1 million customers in our community actively building and engaging with other engineers on future innovations and technology. And there's a real richness in that dialogue that we would encourage you to go and partake in. And we're trusted by many incredible brands, NVIDIA being one of those brands that we're going to spotlight on today. And we're really privileged to be able to partner with those companies who are bringing incredible technologies to really transform the lives and the industries that we're currently operating in. To start with, we're going to dive into some specifics around understanding edge computing. And we're going to do that with our first guest today, Samir from Wevolver. So Samir, I'm going to hand over to you. Take it away.
Thank you, Nick. I hope everybody is hearing me well. Just a small issue with the camera today, but it's all right. Let's just jump right into it. So first of all, Nick, thank you for the kind introduction. It's a pleasure to be here speaking with you and everyone in attendance. I have to start by saying that I am really humbled by your presence and the presence of you fellow speakers today, and it's a pleasure to share this virtual stage with you. And I'm quite keen to listen to both of you and hear your thoughts and insights into this evolving landscape, if you like, of edge computing and AI. So I'll try to make good use of the short time that I have, and be quick and efficient. To reduce latency, if you like, just like edge AI. Am I right? So I'll dive right into it. So I think you can see my screen now. First of all, let me start with this. In my field of work as an editor and a writer on topics of tech and AI in particular, there's usually one thing that jumps straight into my mind as soon as I start thinking of it. And that is, this is fascinating, right? Sometimes it's really important to step out and take a look and admire the amazing feats that this technology has reached, and it's fascinating to say the least. And I bet that's why we're all here today to discuss it. But beyond admiration and fascination comes understanding, and that's what I want to talk to you about today. You say in today's world, technology is say advancing quite rapidly, and in order to keep up with it, we need to understand what it is, how it works, and how it dynamically aligns and synergizes with other technologies in different applications across industries. You see, in the past decade or so, one of the fastest growing technologies has been cloud computing and cloud AI, and rightly so. It's a massively successful technology. However, it didn't take too long to identify particular challenges with the cloud, especially in industrial applications, such as latency, bandwidth constraints, security, and privacy concerns as well. And that is where edge computing began emerging as a highly valuable technology. And I can confidently say it is transforming the AI landscape. I think in a recent report by Gartner, they identified edge AI as the next breakthrough technology. And we'll come to understand how and why it is in a bit. But if I can define edge computing quite well, maybe in the first slide, let's consider that you have a system. We can represent that in a circle, and that's the center of your system is a cloud server, right? And along the edge of the system or the edge of the circle are all your devices, your embedded devices, your IoT appliances, etc. And they're all on that edge of the circle, in action, collecting data. And every time some data needs to be processed, the device sends that data to the centralized cloud server. It processes the data and then responds with information for a decision to be made or an action to be implemented. Needless to say, this process of sending data back and forth has its challenges and potential drawbacks, and we'll come to them in a minute. But edge computing is exactly what its name implies. It's computing on the edge, right there on your device, right? By doing so, you are bypassing all that process of data exchange with the cloud server and bringing your data processor closer to the data source. In other words, you're doing your data processing and computing on the edge, right? And I love technologies and concepts that have a straightforward name, right? Just like, in physics or astronomy as well. Like, there's this thing in space that we cannot see. Everything falls into it, including light. What do we call it? A black hole. But I mean, back to edge computing, the value in it is tremendous, right? Especially when it's combined with the amazing features of AI. But given this simplified representation that I've given you, let's look at what differentiates edge computing from cloud computing, and understand what the main advantages that edge AI seems to provide as compared to the so-called traditional cloud computing. So in this slide here, I wanted to highlight 5 important aspects that I believe would be the most important points of differentiation. And in my opinion, the 5th aspect is arguably the most important of all, because it clarifies and refines our perspective. But I'll come to that in a bit. Let's start first with the more commonly known aspects. And these are location of data processing, the latency and the time it takes to respond to the collected data, the bandwidth usage, and of course, security and privacy concerns. And this last one is crucial for companies in industrial applications, especially because companies as of late have become reluctant to transfer sensitive corporate data to remote data centers they did not control. And this is quite important to keep under management within the company. So if we look at every aspect here, and starting from the location of data processing, we can see the difference in terms of the computing and the processing happening on the device or on the edge as compared to it's happening in the cloud. But at the same time, this difference or this differentiation can be seen in the second point, which is exactly the latency and the response time. And with the advent of edge computing or edge AI, we have seen how much of reduced latency there is with such processing, because you're literally circumventing the whole process of sending data and bringing it back again from cloud servers. So that faster response time helps a lot, especially in applications where you need that real-time processing or real-time computing for very quick split-second decision making, and that's where edge AI, where edge computing seems to sort of excel as compared to cloud. Similarly with the bandwidth usage, of course, because you have local data storage and you have the optimization and categorization of what data needs to be sent to the cloud and what data can be just done locally. This minimizes the reliance or the need for a lot of bandwidth or WAN bandwidth. And as I mentioned, the probably the most important point out of these four is the security aspect and the privacy aspect, because the more you're localizing all of the work on your device, you're minimizing the risk of security breaches and the risk of your data being intercepted, and you're basically relying on the security of your own hardware right there. Now, the fifth point that I wanted to mention, I think it's equally important to all the others, is the fact that not only we always talk about these technologies in comparison, but I think the view of these needs to be looked at in more of a unison type of thing. And the reason I say this is the nature of the process data that we're trying to process, either with edge or cloud, is different. And edge is not here to replace or substitute the cloud, but it's actually here to sort of complement, because or expand our ability to process data in applications where the cloud might not be the best solution. And those are two sort of different categories of scenarios or application areas that I'd like to point out. And one is the time-sensitive scenarios, and the other is the processing-intensive applications. And what I mean by this is when you're in a time-sensitive scenario where you're requiring a real-time processing capability and quick decision-making, edge AI is your guy, right? Like that's the technology that is there that will help you, because it's very important that there's no latency. It's very important that the processing is done quickly. So that's why edge would excel in those scenarios. But when you're talking about applications that require intensive processing, like for instance machine learning or maybe engineering simulation, for instance, or in certain industrial cases where you have reverse engineering of certain parts that you want to produce afterwards, this requires a lot of processing power. And in this case, latency is not the most critical aspect, and it's tolerated. So that's why in those cases the cloud can be the more valuable tool, or more applicable tool here, let's say. But the thing, so what I'm trying to say here is they're not here to replace one another, but they can actually be complementing one another, and they do overlap in a lot of cases. But I do believe that understanding the nature of the data that's being processed allows us to decide on what technology we want to use in order to process that data. Now, if we can move to the third slide. Speaking of all these applications or these examples that I was trying to talk about, if you look at this slide, you'll see this list of all of these different application areas and different industries. And I've mentioned already, these high sort of processing intensive applications. But when we focus exactly on where edge excels, there are really very valuable, very important application areas that are growing, day after day. And one of them, I would say, would be in autonomous driving, which is a very, let's say, trendy topic nowadays. And with all those sensors that require real-time, processing of the data being collected and making the quick decisions to enable autonomous driving, this is where edge can be applicable quite significantly. But at the same time, also, if you think about healthcare as well, that's a crucial point that requires very significant use of edge devices. But I wanted to talk about these three topics at the bottom, because I really think they've been growing, or edge has been growing quite quickly in these areas. And one is industrial and manufacturing. And what I mean by that is there's the concept of smart factories has been growing quite quickly in recent years, and the reason of that is with all the advent of robotics and the way we're using edge devices to ensure quality control, ensure that preventive maintenance of devices that sort of minimizes our downtime, minimizes the lead time to bring in spare parts as well. So all of this aspect is really important when it comes to smart factories, and it's I think it's growing gradually, and I expect that over the next couple of years we'll see quite a significant change when it comes to factories and the manufacturing industry, especially. And I think this is quite timely with the COP28 happening next month. The sustainability aspect also comes into play, especially since when you apply edge computing technology, and you're able to minimize all of the unnecessary energy consumption, all of the unnecessary waste production, and eventually minimize the carbon footprint of the factory. That contributes quite effectively with to the sustainability objectives that companies and basically world leaders have been working for since the Paris Agreement in 2015. Now, in the same way that we're talking about smart factories, we can look a bit further into larger places like smart cities, and that's where actually there's a lot of development happening there with traffic flow management and probably my favorite, smart parking systems. So yeah, with smart cities and the connectivity that's happening between devices across the city, this is a very, very growing application area for edge computing, and I do expect it to grow even further over the next couple of years. As for agriculture, probably the oldest industry of all, I do think that agriculture has been benefiting from edge computing quite significantly, actually, as we speak, and I think it will grow even further. And probably the most important aspect of this, in my opinion, is when it comes to managing resources efficiently. You can mention the monitoring of livestock health. You can mention the monitoring of crop health. You can mention all of the robotic and autonomous ways of mowing and harvesting. But very importantly is actually managing the resources when it comes to agriculture, because agriculture is a resource intensive industry, and being able to use all of these edge devices and sensors and etc. They can help revolutionize this application area or this industry right as we speak, I would say. And this leads me to the next point here. And what I want to say here is, with edge, not only are we sort of finding the right application area and just putting it out there, it's actually creating new opportunities and new potential for new application areas within industries, and that is due to its effective advantages that we can see, by simply applying it, by simply causing that connectivity between those devices. And whether it's in terms of accelerating technologies in industrial and manufacturing aspects, or whether it's in agriculture or medical or healthcare or otherwise, we cannot deny the impact that edge AI has been having over the past years, and it's just the beginning. And I think we will see a lot more of this in the next years. In fact, I was having a short discussion with a friend of mine last week on edge AI and cloud AI, and we came across an article by an edge AI specialist. I think it was from Bangalore, India, and he started his article with something really interesting that resonated with me. And he said, edge AI has become a reality too good to be ignored. And I think that really sums up the current state of edge AI and how it is rapidly growing and how it's gaining momentum and more adoption across different industries. So I really think edge is not only accelerating the adoption of technology within the areas of application that I mentioned, but it's actually becoming more and more central to how we go about doing our business in our industries. But all of this that we've spoken about edge brings me to looking a bit further in a bigger picture, and maybe we can move to the next slide here to have a look at AI in general, right? And we were probably all familiar with the hype cycle of technology, and you can see here all of the different sort of features of AI and the technologies of AI that have been in discussion recently or in application recently. And you can see where cloud AI is and where edge AI is on the graph. And it makes sense given the fact that cloud has reached a point now where people are beginning to understand what this technology is all about, understanding its applications, understanding its impact and its benefits more and more. And edge AI is a little bit behind in that sense. But actually, the position on this graph is not really what I wanted to highlight here. In fact, it's actually the time it takes for the technology to reach that plateau of productivity on the right side. And I think this is very important to see in this graph, because if you look at edge AI and you see that white circle next to it, and that means it needs about 2 years maximum to get to that point. While if you look at cloud, it says it has an estimated 2 to 5 years to get to that point. So given that that aspect there, and given the position of the two technologies on the graph, this means that we expect those two technologies to mature or sort of come to fruition in terms of their productivity almost at the same time. And that synchronous approach really aligns with an idea that has been sort of supported and suggested by a lot of experts in the industry, and that is not to choose either or of these devices, but actually have a hybrid solution of both that combines the benefits of edge AI and the benefits of cloud AI to make sure you have a more holistic applicability of your technology, regardless of what application area you have there. So, for instance, if you require real-time monitoring or require real-time processing power, edge you can basically rely on the edge devices and the edge technology that you have. And if you require further processing power and further computation, especially when it comes to deep learning or machine learning situations, you can basically send all the data to the cloud and do all the intensive processing there. And having this hybrid solution of both can be seamless. It can even be secure across the computing environment. And I really think it aligns quite nicely with how both technologies are developing, especially over the recent 2 to 5 years. So I'm quite excited to see how these technologies converge and sort of align together. And I'd probably leave you with a final quote that I've had the pleasure to have from an acquaintance of mine from ARM, where he actually mentioned that edge AI has the capability to unlock tremendous possibilities, right? And he compared it to the way highways are built, and I really think that resonates and explains the potential and the current capabilities of edge AI, and how much excitement we can expect from edge AI going forward. And I, for one, I'm really thrilled to be a witness of this technology and hopefully be part of it. And I just look forward to see what comes out of it. So I appreciate you listening to me, and I appreciate your time. Thank you very much. Nick, over to you.
Hi, well, thank you, Samir. That was really insightful. I really appreciate your knowledge and expertise on there. And I think that's a great framing for helping everybody understand why this technology is being so rapidly adopted. When you think about the complexity of the inquiries that are now taking place much closer to the applications, and the size of those inquiries require that intensity to be as close to the application as possible. Also, we're seeing the breadth there of the applications, and I'm sure Eddie will help us bring those to life a little bit more. So we're going to move on and help everybody understand the role that NVIDIA really plays in shaping the way that edge computing and also AI at the edge is utilized. Eddie doesn't really need a great deal of introduction, but what I would say, he's one of the earliest employees of NVIDIA, and NVIDIA recently market capitalization tipped over the 1 trillion mark with very few companies, and some say he was one of the most influential members of that journey to get to that outcome. So Eddie, I'm going to turn it over to you to bring to life NVIDIA's role in helping shape the industry.
Great. Hopefully you can hear me now. Thanks, Nick, for that introduction. Probably exploded my head a little bit there, and also from Samir, I think he summarized some great stuff. So what we're going to do is, let me just introduce myself. I'm Eddie Seymour. As Nick mentioned, I've been here at NVIDIA for about 21 years, so seen a great deal of change in the industry all the way through, from my early stages in the gaming area to multimedia. I ran automotive for several years, so as we got into cars from an embedded solution, and then expanding out now as we call it, the Jetson product line or platform for edge computing and edge devices. So maybe next slide, please. Yeah, great. So, so for those of you who don't know about NVIDIA, we're a US-based company based in California, San Jose. But this is a marvelous new headquarters. If you can see, the roof looks like triangles. These are the building blocks for graphics. So that's the imagery you're seeing. But I think the key word here, and what Samir also mentioned, is that we're now in the area of accelerated computing. And that goes back many years here at NVIDIA. If you think about it, we all had, computers or PCs, but we wanted to zoop them up. And, the first one of those really was, gaming acceleration. And that's been the focus all the way through, again, into multimedia and video, into graphics design and CAD. Now we're in the area of AI. And that's the key change that we're seeing. So we're enabling the next generation of researchers and developers through that. And I like to look at this in two ways. There's sort of two industrial revolutions going on. There's what I call the long history industrial revolution, whether it's going from steam power to electricity to the internet to the cloud and now AI, but also a PC revolution. In my generation, we moved from mainframes to PCs. That PC today has moved to the mobile phone as our computer. And now we have, huge amounts of data in the cloud that Samir was talking about that enables their mobile phones to almost be supercomputers. And really what we're going to see is AI extending that into untold amounts of applications that, really will be unmatched as an industrial revolution. And how are we doing that? Maybe next slide. So the key thing from NVIDIA is that we like to call ourselves a platform provider. And with that, what I'm looking at here is, if you look at it over on the side there, you see our graphics for gaming, our RTX. We go all the way through to our DGX in the middle, which is our supercomputing platform for cloud and enterprise and on-premise. Slightly up to the side of that, we see our drive platform, which is an edge platform for automotive business integrated in the car for autonomy. And then over on the side here, we see the Jetson platform, which is our open platform for edge computing and devices. And we'll get into a bit more detail as we drive down into what we use here. Could you just go back? Sorry, one going a bit too quick there. But the key factor of all of these slides, all of these devices, is one architecture. That's what NVIDIA provides on itself. And you know, the key staple energy of that is GPUs. So that one architecture called CUDA, which is a compute unified device architecture, is the common factor across all of their platforms. This makes it easy for customers to develop on one platform and move to another platform if they, based on either their software or their applications. So move to the next slide. So let's just have a look at, and I think a lot of people, what AI is also influencing, what you're going to see here is that there's a technology change that's there. There's a way of programming, or you know, what we call training and inference. And there's also a big business model change here. You know, the way that AI is changing is creating new business models as well. But the fundamental thing is that, you know, we use large data sets, large language models, and we put those in the data center or in the cloud, and we train those data sets to a level of accuracy that we want to actually deploy. And that can be done on our big GPUs, on our data center, or in the cloud, as I say. But then when we deploy them, what we call inference, sorry, go back, please. I'll tell you when to change, thanks. That will move over to our device. And in this case, this is the Jetson, or it could be the drive platform for an autonomous vehicle. We deploy that in the field, and you know, that device is also collecting data. We may need to refine our data sets and our data models, so that will be provided back, and we train it very like a human instance. You know, we learn, we absorb, we do something, we then take it, we found the outcome, and we find it back. A new element of this, though, certainly in self-driving vehicles, and you know, Samir touched on it, industrial environments, we might want to simulate those models before deploying. A bit like a pilot goes into a simulator to train before he actually takes out a real aircraft. So the other box is much about virtual worlds, and we have Omniverse for those sorts of simulation areas that we can also get new data and try that data out, or try those robots out in a simulated world. So this is sort of the model that's basically evolving, and these data models are getting bigger and more refined and more accuracy over time. And this is the new, what I call software model, or training models, or neural networks from a deeper angle. Next slide, please. And you know, NVIDIA provides, again, we're a platform model, and we are basically taking everything which we call the total stack, or the full stack. Full stack. You can be at the lower level of chips and systems, but we provide, you know, toolkits, and we provide. And the big thing we're seeing also in AI, and again touched on previously, is this business that's becoming much more vertically integrated. We talk about smart spaces, we talk about robotics, we talk about automotive, we talk about healthcare, we talk about finance, and these are the key AI applications that we are providing, let's say, toolkits, SDKs, and specialist resources that allow those areas to accelerate in AI. I like to call this sort of an a la carte menu. Customers can take as much as they like from that menu and develop on it, or they may choose to build their own resources on top of those platforms. That's the platform strategy. So that helps the whole industry ecosystem build on top of the work that we are providing, and allow them to accelerate and do whatever they wish at that point. Next slide, please. And as Samir touched upon, you know, I get the question all the time, you know, what area should we focus on? to be honest with you, AI is now touching all areas, whether it be cloud, data center, in-house, or at the edge. We're all seeing it, and the same vertical models that Samir touched on: agriculture, health and life sciences, smart cities, smart retail, industrial and manufacturing, transport and logistics. And we like to look at this is the whole look of what a smart city looks like. I particularly like having the stadium. I have quite a lot of efforts going on with some of our customers and partners in sports analytics, both at the professional and at the amateur level. This is a huge area, and it's certainly accelerated during COVID, where people were still wanting to do their training and athletes, and people wanting to watch them remotely. So huge areas in that, from, like I say, from a professional and amateur point of view. We'll drill in a few of these. I've got some great user cases of some of our partners and customers that are tackling some of those areas and out in there in the market today. So next slide, please. So again, really reinforcing the last slide, it's a huge market, 13 trillion by 2030. You know, manufacturing today, I would say we're still in the area of what I call dynamic AI, static AI. That is a singular camera, but we're moving to the area of dynamic AI, where you've got the sort of robotics or agricultural vehicles that are autonomous. In that case, we need to do a whole wealth of other activities like SLAM, which is location and mapping, which may sit on the top of this AI, building a 3D world real time that we can position, because maybe not everybody has a GPS connection. Maybe it has to be inside somewhere that we have to map and so on. And certainly in the area of mining, you see this, where vehicles are having to cover certain areas. They may have to travel over a boulder. They may be autonomous. So all of that is coming in. And again, that builds on NVIDIA as an accelerated computing platform that people can build upon. Next slide, please. And I talk about a platform and a software-defined AI platform. On this side, you can see we have our standard hardware. From the Jetson point of view, the various modules, we have development kits that you can get working with the OKdo team. But we also have all of our toolkits, the Jetpack, the CUDA accelerators, the TensorRT, ROS operating system, SDKs, gems within our Isaac. So there's a whole wealth of tools and software that NVIDIA provide that allow you to start to build into this area that you may be. And you can take some of those toys, could be pose estimation as an example, or speech recognition. We've built, tools and standard toolkits to allow you to take some of those and build upon it for your particular application or environment. And we can't do this alone. That's the key with AI as well. We're highly dependent on the expertise of our ecosystem and ecosystem areas, which I'll touch on a little bit later. But there is a wealth of knowledge that you may need to bring in to help you build that device in that AI experience from the ecosystem and the developer market. Next slide, please. So yeah, I mean, here's a snapshot today. On the edge side of the house, we have about 6,000 plus customers today. Some of them building small amounts of specialist systems to high volume AI camera solutions to do various traffic management systems deployments. And we have over 1 million developers now on the Jetson platform. These could be individuals, universities, and large companies, all of them as developers building upon our Jetson platform. Some key ones from the Europe here, we got Nanopore under the healthcare based in Oxfordshire. They're in the realm of DNA analytics. They built very large databases to explore the analytics for living things. But they also needed to take that data set out into the field, where you know, they may need to do it in developing countries for agriculture, and they needed real-time analytics to look at those things. We've got people like Viva City here at the bottom. They're in the traffic analytics. They've got deployments in some UK cities like Milton Keynes and Manchester, and they are, you know, basically both controlling traffic real time at the edge and providing traffic management statistics for improvements for local authorities for future planning out there. So a whole wealth. AMRs, you know, basically likes of MIR, who are providing movable machines, and then the areas of retail. And you may have seen some of these retail stores where now you don't even need to take a credit card. You're identified when you're into the shop. You take your items and leave. And this is all, you know, helping, you know, the throughput for those stores. So no particular one. I mean, they're all areas of key growth. Next slide, please. And you know, looking at the Jetson line, I mean, if you look at it, you know, as I said, we've been doing automotive even prior to 2014, but our first Jetson platform focused at AI at the edge was back in 2014. And this slide both shows you the acceleration of platform products and performance that we're driving to today. You know, if you look at it, you know, we were probably, you know, in the 0.5 to 1 teraflop of operation. Now we're in the sort of 200, 300 teraflops of operation as we get up into the AGX line. So, you know, this is the level and the acceleration we're seeing of the sort of performance that customers are now demanding at the edge. Next slide, please. A reason for that is, you know, this is my little Robbie the robot here. You know, he's a dynamic robot doing something. And, you know, he's got a lot of sensors to do what he needs to do. He's got LiDARs and radars. He needs to transpose 2D and 3D cameras. He may have some ultrasonics. He may have video and encoders and decoders. He's got to map himself. He's got to build a model of what's out there. He may need to talk and interact with other humans. And of course, he may go very fast. So we've got safety and redundancy that needs to be processed here. So these are the new age of robots that we're seeing that's requiring these higher levels of magnitude of compute. Next slide, please. And, you know, as I said, there's a whole wealth of software. And I think this is the area I really would like to show. You know, once you start to work on our platforms, you know, they work across all of it. Cloud, you can be working in the cloud. You can be working in the data center on our embedded or edge devices. And we have a whole raft of toolkits at the top level there that, you know, you can take conversational AI toolkits, robotics, autonomous vehicles. And I'm going to pick out 3 that's very prevalent for Jetson. If you go to the next slide. We have our deep stream, which is a video pipeline to help you really get the most out of all of our acceleration, from collecting the data in your camera to actually storing it and analyzing it. You just add your neural network to that. We've got our robotics, which allows you to a thing we call GEMS, which has a whole bunch of tools that allow you to accelerate and build your robot operating and allow you to get up to speed. They could be depth, they could be 3D, they could be SLAM. All of those are available as a toolkit that you can build on the Jetson platform. And then Riva, which, you know, we're going to interact with robots, whether that's speech, text to speech, and ChatGPT showed you some of that. So we're going to have to interface with these robotics and domain-specific areas of application. So I will summarize the end of this is, you know, we have a wealth. It's not just, you know, a hardware level. We have a whole platform. We have great entries, and we'll get into it, of how you might want to start on this journey with us, because That's what most people are doing, is a starting journey, and the Jetson platform gives you that starting point for that edge-based starting platform for getting involved. So with that, at that point, I'll hand back to Nick and we'll go from there.
Thank you, Eddie. Really insightful, and it's clear to see why NVIDIA is a market leader in this space. The sophistication of the offer, that platform, and the breadth of that capability really is something that can power up endless amounts of use cases and opportunities. So whether you're, as Eddie said, whether you're in retail or agriculture or in smart cities, really the technology lends itself to support any of those use cases. But really for us, OKdo plays a role in this partnership with NVIDIA to make, effectively put a face on these technologies and enable you as customers, suppliers and partners to really understand how you can get started and what that adoption looks like. And I just want to share a little bit before we turn to Q&A just on what OKdo is bringing in to this relationship. We've been a partner with NVIDIA for some years, and really that started out, as you've seen on Eddie's slides, around the Jetson Nano development kit to really bring that technology to a much wider audience for adoption. And we've seen some real traction there on some of the use cases and early adoption with the partnership. And so far, that's been a great enabler of some real industrial adoption for these technologies. And it led us on really to an opportunity where we felt that customers were utilizing this technology and designing it into quite sophisticated applications where it may have lent itself better to having the NVIDIA system on module capability laid down in an SBC format. And so we produced the C100 developer kit, which has some enhanced characteristics. It does have that NVIDIA SOM laid down on it for really designing it in and making sure it's robust and fit for purpose in those industrial applications. And our offering broadens out from that hardware of which we manufacture to really offer technologies that are leading the way in terms of the AGX Orin, particularly the 64 that we've now got in stock and available for customers globally to really get their hands on that hardware, but also engage with OKdo to understand what's possible, what other customers have done with it, how can we support them on that journey to realize the solutions and ambitions that they've got. And if we just move on one slide in terms of how we do that, for OKdo, we're looking at making it really simple for you to really get involved in bringing your concepts and smart opportunities to life under our purpose-driven banner of designing a smarter world. What we're really doing here is enabling you to connect with us, with your ideas and opportunities, and engage with our technical expertise and design capabilities to bring the combination of those hardware, software use cases with some of our very talented engineers to look at how we can bring that to life and tailor that for your specific applications. And in doing so, we can collaborate and connect you with a broader array of insights, articles, data sheets, and customers in our rich community that are also building edge computing capabilities in a number of different verticals or use cases. And then we're very fortunate to have the scale of a large PLC organization with a global reach, so we can hold large amounts of inventory, make sure it's available for you, and connect you fully to get it up to speed with the right volumes you need, and ensure that your projects can run as effectively as needed. And really, we're here to make that all accessible in a really seamless, easy and friendly way. We always love connecting with customers, particularly as they're thinking about how they really redefine the future. were those elements of smart, thinking about sustainability and harvesting insights to drive more intelligence right there in the application, whether that's robotics, autonomous vehicles, agriculture. There really is no end to what this technology can enable us to do. And you've heard from Samir earlier why that's important, and how from Eddie that technology is being made available. So I want to just say with that, we've got a fantastic portfolio of products in single board computing, in software, in design service partners that really help bring and connect an ecosystem together for you to really start. So I just want to say thank you to everybody on that, and we're going to take the rest of the time to answer some questions before we then look to close up here. So I'll just welcome Eddie and Samir back with us, and feel free to ask the questions coming through. So there's one question here coming through. What are some of the emerging trends in edge computing that NVIDIA is closely monitoring, and how do they envision the landscape evolving in the coming years? Eddie, I think you touched on this, but did you want to elaborate a little bit more on what you're seeing in terms of greater adoption?
Yeah, I mean, I think, as I said earlier on, most of the AI edge type solutions were static type solutions, and are still there today. You know, if you talk about traffic management, I like to call that the old IVA, intelligent video analytics. The old world of that is a room full of TV sets, if you want, with a security guy or a traffic management guy sat there looking at it. That's the old imagery that we're looking at. But today that's become much more automated. It's applied AI. We can look at red cars and blue cars. You know, certainly through COVID, a key one was, you know, I talked about Viva City, was to train the model on ambulances and fire engines and healthcare. It was really a positive. You know, in other words, we can have our safety and security covered. We can stop the traffic. We can let those ambulances through. So these are some of the easy problems to solve. And again, taking data back and looking at. Now we're in, and Samir showed that, you know, the same area. We're sort of seeing that last mile delivery robots. That's becoming another thing. Again, that was somewhat driven by COVID. We could not interact. We could not deliver. So that drove the last mile thinking with those robotics. I would say today now that extension of healthcare, it's actually, you know, we don't have enough doctors and nurses, right? It's not replacing anybody, it's trying to help. And, you know, so we're going to see intelligent beds, intelligent monitoring in healthcare, even healthcare at home. And you saw, you know, social interaction is also very difficult in this new world. So certainly, as you see in Japan, you're going to have those sort of robot interactions where it ends up being somebody that they can interact with. So I think all the things we see today in the world that are difficult, AI is actually going to help us solve, because, you know, they're areas that we're just not yet expanded enough to see.
Thank you, Eddie. Yeah, it's interesting stuff, isn't it? As we're pushing the sort of the limits of technology and the rapid evolution of that. So, I just want to come over to one of the points that you mentioned. There's a question here talking about security and privacy. So the question is, how can organizations ensure that security and privacy of data in edge computing environments, especially in industries with stringent regulation requirements? You talked about the importance of that, particularly with the amount of data processing going on that edge. What are your thoughts on that?
Yeah, I think that's a really, really good question, actually. And it's probably one of the most important aspects when it comes to data processing within industrial applications. And I think, some of the most important sort of strategies to address these concerns can come in the form of data encryption, for instance, whether it's for data, whether it's data in transit, we use secure communication protocols, or whether it's data that is stored on the edge device and encrypting that data. But at the same time, you have to also look at the physical aspect, the physical security of the device as well, and looking at how to make sure that these devices are protected from tampering, from theft, etc. And at the same time, there are also the sort of the protocols for access control and the authentication that sort of prevents unwarranted access or unauthenticated access to these devices. So there's a lot that goes into, there's a lot of strategies that go into securing such devices and securing data processing as well. But of course, I think there's still a lot of room for improvement when it comes to security, whether it's on the edge itself or in relation with the cloud.
Thanks, Samir. Yeah, really thought-provoking, actually. And so there's some other good questions here coming through in terms of customer application, use cases, adoption. And one that sort of resonated here with me, we were touching on medtech and actually the advancement there in medicine and big data processing around that. There's a question in areas of medical technology, how much are you influencing collaboration within the NHS at the moment? And I mean, Eddie, it'll be good to get your view because you're seeing a much broader adoption of this technology. But from an OKdo point of view, we're seeing great adoption of this, particularly with the AGX Orin, because the power and processing capability of that platform is really unrivaled. And particularly when you're thinking about the magnitude of data processing in medicine and research, we're working with some customers there on how they can utilize this technology. The use cases are quite narrow at this point in time, but actually have a great opportunity to extend from that. And we're really excited about that. It connects with our purpose to make, a smarter world that actually healthcare has to revolve around. But Eddie, just from your point of view, are you seeing that broader adoption in medtech? Any other examples you could share?
Yeah, I mean, I think one of the strong ones, certainly on the Orin side, is endoscopy. Endoscopy is looking cameras, taking data. That's been a strong area, both from the data point of view and analysis. Cardiacs also, we're seeing, we actually have one company that actually provides cardiac monitoring. These are people that have had a heart attack or are at risk of heart attack. They can carry a device. They can carry an instant thing that requires medical help on an instant basis. So, all of those things, I mean, there are devices are being thought about. And then we get into the, like I say, the more of the monitoring. So, sophisticated health beds or monitoring beds. I don't know if you see lots of equipment around. You're going to see integration of, one area of bringing all that together from a monitoring point of view. So they're probably some of the more prevalent ones now.
Yeah, that's great. Really interesting. A couple more questions here then before we look to close in the interest of time. Samir, I'm just interested in getting your view on this question really. Talking about sort of the adoption really of certain use cases, but particularly thinking about sustainability characteristics. That's hugely important in the ESG context. There's a question here. Can you share some insights into the environmental impact of edge computing compared to traditional cloud computing, especially in terms of energy efficiency? I mean, there's obvious round trip aspects to that, but what are your views on that topic?
Yeah, I mean, of course, the obvious aspect is when it comes to the data centers of cloud computing and how the difference in energy consumption between such large data servers as compared to what edge technology provides. So the saving on energy consumption between edge and traditional cloud computing is quite evident from that point. But it's not only when it comes to the energy being consumed, but actually the impact that comes from implementing edge sort of technologies into, for instance, energy plants and or general manufacturing plants as well, where it enables this sort of how can I say it? the process improvements when it comes to product quality, when it comes to reducing the manufacturing waste, et cetera. And the way this is done is you can utilize and apply machine learning models that are designed to run on edge devices within a system of a manufacturing plant, and this will enable further enhancements in terms of predictive maintenance, etc. And I can identify problems or potential problems with equipment. It can predict the quality of a certain product that's being developed. It can even avoid certain flaws within the product, and generally improve the stability of the whole process within the manufacturing plant. I think there was a use case that I was reading about, we're actually implementing such a combination of edge AI with or machine learning with edge devices in a manufacturing plant. It enabled more than 30-35% reduction in carbon emissions from the manufacturing plant, and that's a really significant number in emission savings. And I think this is just the beginning when it comes to that side as well.
Yeah, I fully agree. And I think that is a real important characteristic when we think about that data harvesting to draw intelligence closer to the application to make more informed decisions on energy consumption. I think some of the examples you were alluding to in agriculture obviously are standout aspects, but I think to your point, the use cases and applications are really only just sort of starting to be kind of highly adopted. Actually, there's an endless opportunity around some of these, particularly in smart cities and so on. But look, I just want to draw this to a close because we've taken an hour of everybody's time. But firstly, I just want to thank everybody for giving us that time. We really appreciate you joining in with Eddie and Samir and I. We've talked about how edge computing is different to cloud computing, but actually the power of them collectively is really where the endless opportunity lives. We've talked about how NVIDIA is bringing the leading technology to the market. Actually, it's widely adopted in lots of different use case and verticals. And OKdo is here to support in the assistance of that adoption on a global scale. And we love to hear from everybody on the adoption, how you're reinventing the future world that we live in. So that just leaves me to say a massive thank you to Samir. Appreciate you joining. Eddie, appreciate you joining. And always great to chat to you both. Take care, everybody, for now. Thanks for your time.
Bye.
Thank you. Ciao.